Welcome back to another video on the GCSE Physics Paper 2 topic of forces, and in this lesson we're going to look at acceleration. Before we start, remember the top tips for getting the most out of these lessons. Do not have any web pages or windows open that will distract you. Answer all of the questions, they will help to make sure you understand the new content. Switch off your phone, or at least have it in a different room. It's the biggest distraction you've got. And finally, try to complete the lesson in one session. It will really help you to understand what has been covered. The plan for this lesson, as always, we'll start with some retrieval practice. We know we need to go over previous topics to make sure we don't forget anything. We'll have a look at the new concept of acceleration. You'll have some time to embed those key concepts before it's your chance to have a go and develop your understanding with some practice work. What you're going to need is a mini whiteboard or a pen and some paper, possibly some revision cards, an exercise book or a notepad to write down your new content, a mini whiteboard or a pen and paper or someone who can quiz you for the embedding, and an exercise book or notepad again for you to complete the practice work. So pause the video and get yourself organised. Let's start with some retrieval practice. Here's the first retrieval slide. Pause the video and answer the questions on some paper or on a mini whiteboard. Here are the answers. Any you couldn't answer or weren't sure about, you should write down on revision cards or in a notebook so you can go back over them later. Pause the video and do that now. Second retrieval slide. Pause the video and give these questions a go. Here are the answers. Make sure you pause and write down any you weren't sure about. And the final retrieval slide is to help you remember what was covered in the previous lesson. Pause and have a go. Again, here are the answers. Pause and write down the ones you struggled with. On to the new content. You'll need an exercise book or a notepad so you can write down the questions and answers as they appear on the screen. You will need these for the embedding part of the lesson later on. Pause and get yourself organised. Before we start looking at acceleration, we need to understand this term velocity. So what is velocity? Velocity is speed in a given direction and is measured in meters per second. As there's a direction associated with it, this makes velocity a vector quantity. So to understand how speed and velocity are different, imagine you've got an object and it is moving in this direction and it has a speed of 30 meters per second. Its velocity is also 30 meters per second. The difference comes though is if this object now moves in the opposite direction. So if it goes back the opposite way at the same speed, it's traveling at 30 meters per second. But velocity is a vector quantity, which means we can associate a direction with it. So that means we could say the velocity is minus 30 meters per second because it's moving in the opposite direction. We say it's a minus going this way, whereas it's a positive going in this direction. Now let's take that same object moving at 30 meters per second and imagine that it is moving in a circle. So someone on a roundabout at a park, for example, or an object in orbit around the Earth. Its speed is still 30 meters per second. It's still covering 30 meters every second. However, because it is always changing its direction in order to complete this circular motion, it's always turning left in this case, its velocity is constantly changing. It cannot have a consistent velocity because its direction is always changing. At no point is it traveling in the same direction. Let's now have a look at what acceleration is. So what is acceleration? Acceleration is the change in velocity in a period of time, and that is measured in meters per second squared. What is the equation for acceleration? Acceleration equals the change in velocity divided by time. As a symbol equation, A equals delta V over T. This triangle here is the Greek letter delta, and it simply means change. How do you calculate a change in velocity? It's the final velocity minus the initial velocity. And what does it mean if you have a negative acceleration? The object is decelerating, so it is slowing down. Now it's your chance to embed those concepts. You can use the look, cover, write, check method, or get someone to ask you the questions and you tell them the answers. Pause the video and do this now. Now it's time for you to practice using the concepts we've covered in this lesson. Pause the video, open up your exercise book on Notepad. First, I'm going to guide you through how to answer these questions. Copy down my workings as I go through them. I've got my questions printed on a sheet, but you can write them out into your exercise book and then just answer them below. So question number 1, an object accelerates from rest, 0 speed, to 14 meters per second in 2 seconds. Calculate the acceleration. So the first thing I'm going to do is I'm going to go through the question and pick out all of the information I'm going to need in order to answer the question. So, an object accelerates from rest to 14 meters per second. Well, there's my change in velocity. Its final velocity was 14. Its initial was 0. So 14 take away 0 is 14 meters per second. 2 seconds. Seconds is the unit of time, so my time is 2 seconds. And then it says calculate the acceleration. So the instruction is to calculate A. And I'm going to write a question mark to remind myself that that is what I'm trying to work out. What equation do I know that links all three of these? Well, I know that A equals delta V over T. So I'm going to substitute these values into this equation to give me A is 14 divided by 2, which equals 7. So A equals 7 meters per second squared. Always remember the units. Question 2. An object starts at 100 meters per second and decelerates to 75. So there's my change in velocity. So its final velocity was 75 and its starting was 100. So 75 take away 25 is minus 25. Velocity is a vector quantity, so it is okay to have a negative. Over a period of 5 seconds. So my time is 5 seconds. And it says calculate the acceleration, so A is what I need to work out. The equation that links all of these is A equals delta V over T. Substitute my values in, and that's going to give me minus 25 over 5, which equals minus 5. My acceleration is minus 5 meters per second squared. Says it's minus 5, I know that it is slowing down, it's decelerating. Question number 3 then. For an object with an acceleration of 6 meters per second, so I've now got an acceleration of 6 meters per second squared, what is the change in velocity over 15 seconds? So I've got a time of 15 seconds. And it says, what is the change in velocity? So delta V is what I need to work out. I know my equation. A equals delta V over T. Substitute my values in, gives me 6 equals delta V over 15. I need to rearrange. So I want to get rid of the 15 here and just leave delta V on its own. So it's currently divided by 15. So I do the inverse, which is multiply by 15. Do that on both sides. 6 times 15 is delta V. Run out of space. So that is, if I type that into a calculator, 90. So delta V equals 90 meters per second. And question number 4, for an object with an acceleration of 45 meters per second. So A equals, 0.45 meters per second squared. Find the time, so T is what I need to work out, to accelerate from rest to 3 meters per second. So the change in velocity is going to be 3, which is the final velocity, take away 0, the initial, which is therefore 3. A equals delta V over T. Substitute my values in, 0.45 equals 3 divided by T. I need to find T. So I'm going to rearrange. And having divide by T really complicates it. So I'm going to get rid of divide by T. I know I want to find T, but having it as a divide makes it complicated. So I'm going to multiply by T to remove the divide by. So do that on both sides to give me 0.45 lots of T equals 3. Now that's really simple. I want to get the T on its own here, so I'm going to divide by 0.45. Do that on both sides. T therefore equals 3 divided by 0.45, which equals, if I type that into a calculator, 6.667. So my time is 6.7 to 1 decimal place seconds. Now it's time to practice independently the concepts that have been covered in this lesson. Pause the video and work through these questions. Here are the answers to the first 5 questions. Pause the video, check your answers and make any corrections. And here are the answers to those final 5 questions. Again, pause the video, check your answers and make any corrections. That's all for this lesson. Make sure you go back over all the concepts from this lesson, including the retrieval practice, in order to develop your long-term memory. And I will see you next time.